Okay, so give you a couple minutes to work on these problems here. Let's take a look, see how we're doing. For number one, 42 is 70% of blank. So 70% is going to be 70 over 100 equals, the 42 is 70. That implies the 42 goes with the 70 on top. Of blank, remember we read that as out of blank, implies that missing number goes on bottom. Then we cross multiply and divide. 100 times 42 is 4,200. We divide by the 70, giving us 60. So the key is we multiply the two pieces that are diagonal, the two numbers that are diagonal, and we divide by the third number. Number two, 52 is blank percent of 40. Well, we don't have the percent there, but we're still going to start with it. We just do blank over 100. Whatever that percent is, it's going to be out of 100. Equals, on the other side, 52 is blank percent. That implies that 52 goes with our missing number. Out of 40. Implies the 40 goes on bottom. Now the two numbers that are diagonal are the 100 and the 52. We multiply those. You get 5,200. And the third number, the one that is diagonal with our missing number, we divide by that. So we're going to divide by 40. 5,200 divided by 40 is 130. So 130 out of 100 or 130%. 52 is 130% of 40. Number three, blank is 25% of 68. So if 25% is 25 out of 100. Blank is 25%, so that implies that missing number goes with the 25. Of 68, again, read that out of 68, implies the 68 goes on bottom. And again, we cross multiply and divide. So the two numbers that are diagonal are the 25 and 68. We multiply those to get 1,700. The third number we divide by the 100, giving us 17. 17 is 25% of 68. Any questions on that? Number four here is a little bit different, a little bit trickier, because I don't give you the base. So here, Kim saves $294 with a trade discount and pays $3,906. What percent is Kelly's trade discount? So we talked about making tables and labeling things. This is one that would be very helpful with. So we have the list price or the full price. That's the full amount. We're not given that dollar amount here, though. From that, we subtract the discount. And that gives us the amount paid. Remember, in problems like this, each item is described by two numbers. One of them is the percent, and in this case, the other is a dollar amount. Now let's go through the problem and pick out what we have. We have $294 represents the discount. So on the dollar side, by the discount, we put 294. We have 3,906. That's the amount paid. So again, on the dollar side, by the amount paid, we put 3,906. Now, you can do other versions of the table or other ways of organizing it. This is just an example of one way to organize this information. Now, it looks like that's all we have in this problem. There's one number that's there in all of our percent problems that isn't spelled out in the problem. That's the 100 and the percent. The 100, remember, represents the base amount or the starting amount. Here, that would be the list price. So on the percent side for the list price, we put in 100 because that represents 100%. Now there's another number we can find, and that's because we have 2 out of the 3 pieces. We can find the third. Over here, we know that the list price minus the discount gives us the amount paid. So we can work backwards to do the amount paid plus the discount. Gives us that the original list price had to be $4,200. That's the number that goes with our $100. That's our base amount. We need that. And what we're looking for is the percent of the discount. So that's right here, this percent discount. So I can set up a proportion. Now notice the 100 here goes with the list price. The other number for list price was the 4,200. That has to go on the other side lined up with the 100. Things in our proportions have to line up. Now we're looking for the discount. We don't have the percent amount there. That's what we're looking for, is that percent amount. But we do have $294 for the dollar amount of that discount. That correctly. So to find the percent, we cross, multiply, and divide. 2 numbers that are diagonal are the 100 and 294. That multiplies to 29,400. Then we divide by the third number. We divide by the 4,200, giving us 7. That's 7 out of 100, or 7%, is the percent of Kelly's discount. Now, this is a very tough problem, and it illustrates a couple of things. The biggest thing whenever we're dealing with percents is to identify that base amount and make sure we know that whether the number we are given is that base amount, or if we have to do something else like we did here to find that base amount. That base amount is always what's going to go with the 100 in our proportion. Second thing this illustrates is the importance of organizing your information a little bit. I use tables like this a lot just because it goes a long way to organize the information. There's a formula in there. List price minus discount equals amount paid. It doesn't matter what words you use in there. You can use any words you want. It's the relationship that matters. And so having that relationship graphed out and organized like that helps you put in the information and see what matches up with what. Any questions off the homework from yesterday? Okay, well then, there's a quiz out there on percents. That's for today. Technically, I have it set to be due by noon tomorrow, so you've got the rest of the day today and the morning tomorrow to work on it. It'll cover the percents. It won't cover any of the new material that we're going to talk about today. Today we're going to talk about some applications of percents. And more specifically, we talked about that rate method of percents and how that rate method was really useful if we had the base amount. And it was the base times rate equals a portion. And we even mentioned that one of the common applications of that rate method where it was most useful is in interest. So I'm going to talk a little bit today about interest. And we're going to start out talking about simple interest. Simple interest is called simple interest because it literally is the simplest way that interest can be calculated on a loan or an investment. In a simple interest situation, interest is only calculated if one of two things happen. One, the end of the term. It's a 6-month investment, you calculate the interest at the end of 6 months. A 2-year investment, calculate the interest at the end of 2 years. Or if there's an action on the account. What does that mean? Well, if you pay into the account or draw out of the account, that's an action. So when that action occurs, technically, before that action can occur, they figure out what the interest is and add it in, and then they perform the action on the account after the interest is added into the account. So to find the amount of simple interest, our formula is I equals P times R times T, where I is the dollar amount of simple interest. P is principal. Principal is the starting amount. It is the base amount. R is rate. Remember, rate is just a percent in decimal form. And T stands for time in years. Time is always expressed in years in this formula. So you can see if your time is 1 year, this really is just a rate calculation. Is your base amount, which is your principal, times your rate, and that gives you your interest, which is your portion. So let's take a peek at this. Let's say we are going to invest $4,000 at 8% simple interest for 3 years. The amount of interest, I, equals the principal, 4,000, times our rate. Well, 8% becomes 0.08 as a rate, times our time, 3 years. Multiply that up, I believe that's $960 in interest. Well, then there's an additional item called maturity value. This is the balance after interest. And this formula is quite simple. The maturity value is your principal, your starting amount, plus your amount of interest that we just calculated. So for this problem here, the maturity value would be the $4,000 in principal plus the $960 in interest. Or $4,960 maturity value. Well, let's do a problem where we do this all together. Find the maturity value of $7,000 invested at 2.4% simple interest for 5 years. Now, even though I ask for the maturity value, I have to start out by calculating the interest because I need the interest to find the maturity value. So I equals PRT, the principal, 7,000. Our rate, 2.4% becomes 0.024. And our time is 5 years. 7,000 times 0.024 is 5. $840 in interest. Now that may seem like a lot, but that is over 5 years. Now our maturity value then is we take our $7,000 principal plus our interest of $840, get a maturity value or an ending balance of $7,840. Now these two examples I did here are accurate, but they're not terribly reasonable. You might think that the interest rates are a little high, and they might be. But the biggest thing is banks don't like to do simple interest on a 5-year or even a 3-year investment. Banks don't like to go more than 3 to 6 months without calculating interest. Like on this one here, if they did simple interest, at the end of 5 years, there's $840 in interest out there that they owe. Rather than having that all go on the books at once, they'd like to keep track of that as they go. So they don't want to wait 5 years to figure out what they owe this person or what that person owes them. So simple interest typically applies on short-term items between 3 and 6 months long. Some banks will only go 3 months without doing something else. Others will go up to 6. But very seldom do they go more than 6 months with simple interest. So let's look at another example here. Find the maturity value of let's say $8,000 invested at 3% simple interest for 3 months. So again, first step is to find the interest. I equals PRT. Our principal is the $8,000. Our rate is the 3%, so that's 0.03. Our time, now you remember we said our time is always expressed in years. Here we have a time of 3 months. Since there are 12 months in a year, we express that as 3/12. Now I realize you can reduce that to 1/4, but why make the extra work? Just put it down as our number of months over 12 months in a year, 3/12 of a year. When you calculate this out, you don't have to use the fractions. I'll show you here. You can simply do 8,000 times 0.03, and then instead of trying to enter a fraction, you just do times 3 divided by 12. Gives us $60 in interest. So the maturity value is our 8,000 principal plus the $60 in interest, giving us a maturity value of $8,060. Any questions? Well, let's go back to a previous example, but work on it something a little more practical. we had that, I believe it was $4,000 at 8% for 3 years. Well, for 3 years, they don't like to use simple interest. They would use something called, excuse me, compound interest. In compound interest, interest is calculated and added every set period. Whether that set period is every month, every quarter, every year, it is every set period of some sort. And then after that, you receive interest on the previous interest. That's why it's called compounding. It builds, it compounds interest on top of the interest. Well, let's go back to that $4,000 at 8%. But this time, instead of simple interest, we're going to say compounded quarterly. For 3 years. Well, to calculate that, let's set up a little table here. We have our quarter. We'll have our beginning balance. We'll have our interest. We'll have an ending balance. So in our first quarter, we start out at $4,000. Our interest, back here, interest is going to be 4,000, our principal, times our rate of 0.08. Now our time is 1/4 of a year, 1/4 of a year. That calculates out to give us $80 in interest. So our ending balance, our principal 4,000 plus our interest of $80, $4,080. We start quarter 2 then with a balance of $4,080. Our interest is found as that principal now. 4,080 is our new principal. Times 8% is still 0.08, and times 1/4 of a year. Comes up to $81.60. So we add that, the 4,080 plus the interest of $81.60. That's $4,161.60 is our ending balance. Now that's only 2 quarters. That's only 6 months. To get to the end of 3 years, how many times am I going to have to do this? 4 times a year for 3 years, 12 times.
12 times.
Yeah, I don't want to do this 12 times. That's a lot of work, and I don't feel like going through it. So let's look for a pattern in a shorter way of doing this. First of all, right here, every quarter, we did 0.08 times 1/4. Well, 0.08 times 1/4 is 0.02, or 2%. Now that makes sense. If it's 8% per year for a whole year, it would be 2% for a quarter, 1/4 of that. So that makes sense. And if you look at what we did each quarter, we had a beginning balance, we added in the interest, We had an ending balance. The beginning balance was 100%. The interest, we just said, was 2%. It's 1/4 of the 8% because it's only a quarter of a year. 100 plus 2 is 102%. The ending balance each quarter was 102% of the beginning balance. So if I look at quarter one, I started out with $4,000. If I multiply by 1.02, remember 1.02 is 102%. I get $4,080. That was my ending balance at the end of quarter one. Take that $4,080, which is my beginning balance for quarter two, times 1.02. $4,161.60. That was my ending balance at the end of quarter two. So I can just keep multiplying times 1.02. Again, how many times?
4.
Well, 4 times for a year, 12 times to get me to 3 years. Once for 4 quarters in a year for 3 years. Well, rather than doing it 12 times, I can use a shortcut. In math, if I'm going to multiply by the same number over and over again, I can use an exponent or power. 4,000 times 1.02, power of 12, that's 12 periods, 4 periods a year for 3 years, gives me 5,072.97. Now that's compounded. Compound interest. If you remember our number from simple interest from up above, it was $4,960. So you can see compound interest gave like almost $113 more in interest over the term of that investment because you got interest on top of the interest you've previously earned. Now I have to show this next piece just to clear my conscience, basically. So many of you are in your late teens and early 20s. For those of you who aren't, I apologize. This is just as depressing for me as it is for you. Let's say you're 20, let's go 21 years of age. Right now you're in school. Most of the time, if you're in school, that means you have to spend a lot of time at school. You maybe can't work as much, so you try to live a little cheaper. You might either living with parents or living with roommates. Continue to drive that older car. You don't go out to eat very often. You eat as cheap as you can. You live cheaply to get yourself through school. Well, in 2 years, once you're done with school and you're looking at that first good job, getting paid, making decent money, a lot of people want to move into a nicer apartment, buy a new car, new truck. But if you held off for a year and just stayed living cheaply for even just 1 year, probably would not be that hard to save up $5,000. Now, let's look at age 66 to retire. The only reason I did that is because it's going to give me a nice even 45 years from 21. For most of you, Social Security full retirement age is going to be 69 or 70 years old. For me, it's right around 68 because of my age. But that's still 45 years. Now, the average 40-year return in the stock market, even in periods that include huge crashes, huge recessions, is between 13 and 14% a year. So let's just go with 12% interest. 12% return. Now, obviously, you're not going to get that at a bank. This would be going to an investment planner, like a Fidelity, a Merrill Lynch, State Farm, Allstate. I think there's Edward Jones has offices in Rice Lake. Any of those places that do investment planning for you, financial planning. And they would get you in an investment that's going to be way better than just throwing it in the bank. So, if we get that 12% interest, or take our $5,000 times, now 1.12, what that is, that's 112%. That's what we saw in the last problem. We did 1.02 for 102%. Same type of thing we're doing here. We're going to say it's compounding once a year, so it's the full 12%. And it's going for 45 years, so we're going to go to the power of 45. Now, before this comes up, anybody want to take a guess as to what this is going to be? This is rather an impressive number. $819,938. At 21, $5,000 investment. If you do well, if you invest it well, could be over $750,000. Could be over $800,000. That's pretty impressive. That's at age 21. Well, let's say you decide you're going to wait a while. You know what? You're young, you get out of school, all your friends are getting new trucks, four-wheelers, whatever. So you spend some money and you wait till you're 31. And then you decide, okay, now it's time to worry about retirement. That same $5,000, if you can manage to save it. Now at 31, there's a much better chance that you have kids, a house, and a mortgage. So coming up with that extra $5,000 might be a lot more difficult at age 31. Let's say you can still get that same 12% interest, but now it's only going to sit there for 35 years. You're only going to get, oops, I got an extra zero in there, $263,998. Less than 1/3 of what you got up here, just by waiting that 10 years. Let's say you wait even longer. So at 31, you had kids, you decide you need to pay for them. You wait at 41, you finally decide, okay, time to do it. Put away that $5,000. Let's assume you can still average 12% interest. It's only going to be in for 25 years. You're only going to get $85,000. Now let's look at that. It is basically, it's exactly about 1/9. It's basically a 10th that you'll get. If you wait till 41, you'll get about a 10th of the amount back is what you would have if you invested it at 21. There's a lot of power in being young. You get out of school, if you have a company that has a 401k program, a matching program especially, because that's free money. If you put a matching program means if you put $100 away, the company will put $100 away to match it. So you end up getting $200 for just your $100. It's a tremendous deal. Since we got a little time here, I'm going to show you an example of how this could turn out. So let's say you start at 21. And we're going to go to 67, 68 actually. That'll probably be about retirement age for you guys, 68. Let's go 5,000 a year. Gotta wait for the computer to think for a second here. Here it comes. We're going to label these as money. So starting at 21. Now, the reason I use 5,000, partly because it's a nice round number. The IRS, it used to be you were allowed to put $5,000 a year away in retirement accounts. They raised that a few years ago to 55, and either this year or next year it goes up to 6,000. So you could put a little bit more than that away if you wanted to. So, in fact, let's go conservative here. Instead of 12%, let's only do 10% return a year. At the end, if you start at 21 and do that 5% every year, even at a 10% return, you end up with $4.8 million at age 68. Now, if you think it doesn't make a difference, if you think, oh, I'll get 7 or 8%, play it safe, it won't make that big of a difference. This was 10%. If I change that to 12%, it'll go from $4.8 million at 68 years old to twice as much. A difference of 2% interest over 47 years will double your money. So we're going to put it back at 10% here. In case you do want to play it a little bit conservative, middle of the road. Now I want to look at a couple of scenarios. So in this first one, this person here decides at 21, you know, I don't have kids. Now is the time to put money away. It'll be easy. And for the next 8 years, they put money away. And at 29, they have a kid and say, okay, time to pay for the kid. I'm going to stop putting money away. They still have $2.5 million there. What about this person over here? This person says, you know what? I am young. I want to play. I want to have a four-wheeler. I want a new truck. I want to go do all these things with my friends. So they spend the next 8 years playing with their money. And then at 29, they decide, okay, now I'll start putting it away. This person here put the money away only for 8 years. And then after that, never put another penny away. Every penny they made after that, they could use to play. Over here, they saved from 29 to 68. For 40 years, they saved. Guess who comes out better? That person, even though they paid in $5,000 a year for 40 years, never catches up to that person that only paid in for 8 years. That is the power of being young. When you're thinking about retirement and investing for retirement, the next 10 years of your life, no matter what age you are at, the next 10 years of your life is worth more than the rest of your life. I'll stop preaching now. I just wouldn't feel right if I didn't put those examples out there for you to see. I realize it's easier said than done to try to do that as you're coming out of school, but the information is there. It really is a good idea. Okay, so we have homework. Your homework is out of the little book. Units 17 and 18 on interest and discounts. The odd-numbered problems. Also, tomorrow is test 1. I will not present any new material in class tomorrow. The test will be available starting at midnight tonight, or midnight tomorrow morning, however you want to put it. And it'll be available all day tomorrow until 11:59 p.m. So at some point tomorrow, you have to access that test, complete it, and submit it. I will be logged in for class tomorrow, but as I said, there won't be any new presentation or any new information offered. I will simply be in class so that if you have questions on the test, you have a time where you can log in and ask me that question immediately instead of having to email and wait for an email answer. If you have the test done and you're comfortable with it, there's no need to log into class tomorrow, just so you're aware. Also, don't forget, you have that percents quiz. That we assigned at the beginning of the hour that is due tomorrow, noon. Well, so you have that quiz due tomorrow at noon, and you have that test due tomorrow at 11:59 p.m. So you got a couple of things to do, and that will wrap up Unit 1 for us. And we have a few minutes here if you guys would like to start working. Otherwise, I won't force you to sit on the network and work. If you have questions, I'll see you tomorrow on the test. You are welcome to email me anytime through the day. Otherwise, if I don't see you tomorrow, we'll see you all on Monday.
On that first test, will we be able to fix the answers in